Hello and welcome everyone. This is Benham from Banks and Markets. In this video today, I am going to continue my discussion related to the investment appraisal techniques. In the other video, you listened about the net present value, how it can be computed, and we also appreciated that this method is superior as compared to some others such as payback period and accounting rate of return. Now we would like to learn on another technique called internal rate of return. Now, to help you understand what I will do, I will copy some data from this worksheet. In fact, I will copy the whole worksheet and we will just focus on one project here, which is project A. And this, as of now, is giving us 22.22 as the project NPV at 20%. What we will do now is we will find it, let's say, for 10%, and we will increase to let's say 8, or we can have just 5%, and then continue to increase that. And we now want to find out NPV for this cash flow for all these discount rate. Okay, and let's see what the NPV becomes. So here what I will do is I will just make use of the 10%, which is here 1 plus the rate, and the time is here. Okay, I just need to lock few things, which is I'm going to lock this row number. Here I'll lock the column, and where it is this, I'll lock the row again. Okay, so having done this, now I should be able to drag it along and therefore make it applicable for all. So if I get the same number here, 6672, which I have, this is working, this has not changed, this means this is all correct. So now I also have the NPV. And using this NPV, what I will do is I will insert a line chart. Now you can see here, this line chart basically shows the NPV profile at various discount rate. So when I said various discount rate, here I can put those discount rate in x-axis, and the discount rates are all these rates. So now we have the rates here. Can you see that closer to 40%, the NPV is equal to 0? And now that I would like to show you the formula of IRR, and this is the formula for IRR. So can you see that here the formula is exactly same as the formula for NPV, but what IRR does is IRR forces the NPV to become 0. So instead of R, what we are saying? We're saying IRR. And when we compute this, what do we need? The NPV 0. So IRR is a rate that forces NPV to become 0. And that's what we see here. This discount rate, which is making this NPV, is actually the IRR. So let's see if that is the case, which then basically means we now want to find the IRR. To compute the IRR manually through a process called interpolation, what you need to do is basically do this. Okay, so you need to apply this formula, which is lower rate plus NPV at lower rate divided by NPV at lower rate minus NPV at higher rate times higher rate minus lower rate. So that's basically the interpolation formula to capture IRR, This is what we need to do, equal lower rate. So when it says lower rate, you can take something like 10%, plus when it says higher rate, you need to take one for which the NPV is negative. So let's take 50%, which is here, the NPV at lower first. Okay, so that's NPV at lower divided by NPV at lower again, minus NPV at higher, which is this minus 11. So you see here, minus and minus becomes plus. So what you are doing effectively is NPV at lower rate divides the total, which is 38 plus 11. Okay, and then you just need the higher rate minus low rate. Higher rate is 50 minus low rate is 10. Okay, so that's basically the IRR. So here you found the IRR, but this was perhaps a little bit lengthy process in terms of computation. So what you can do if you want to be quick, then you can just ask the computer to give you the NPV, sorry, IRR. So Excel given IRR, internal rate of return. For that, you need to do simply equal IRR and then capture all your cash flows. That's it, and you get it. And now you will say this is different than this number here. Okay, Excel given IRR is different than the manually computed IRR. So which one is correct? In a way, both are correct. And if you ask the precise correct, then Excel given is precisely correct. The reason why this is different than this is because the spread between the higher rate and lower rate is large. Okay, so you see here we have this spread 50% minus 10%, which is 40% point spread. So if you are able to reduce it, then it will become closer. So for that, what you can do is you can here change the lower rate and higher rate. So if you put something like 35 and 45, 35 as low rate and 45 as high rate, then you'll get an answer closer. Okay, so that's something I can show you here very quickly. So lower rate, let's say 35 plus NPV at lower rate, which is this number, divided by NPV at lower rate again, minus NPV at, let's take, what did I say? We can take 40% actually. This and higher rate 40% minus lower rate 35%. And you'll see this answer is going to be very closer to the Excel given IRR. Okay, so that's also 38%. Okay, that's fine. So we understand IRR, and we also know that the research says IRR is more widely spoken or used by CEOs or CFOs while talking about investment decisions. But let's not forget the fact that IRR has some issues. So therefore, now I'm going to quickly talk about those issues. Number one, the issue is related to what we call crossover rate. Okay, and I have this example to talk to you about the concept of crossover rate. Firstly, let's find out the NPV and IRR for this using computer. So IRR, and you get the IRR quickly here, 20% and 26%. So if you compare these two projects using IRR method, then you will say machine is what we need to take because machine project has higher IRR. Now if you ask NPV, then here let's first say that this rate is 7%. This rate therefore is also 7. Now if you compute NPV, then you first need to take rate, then values. This is Excel way of finding IRR, NPV. Okay, then all these values plus you put plus sign when your cash outflow is negative. this number here, and this is what you get, 4,912. What is it for machine? 4,686. So what does this mean? Now NPV is higher for labor project. So according to NPV, it should be labor project that should be taken. According to IRR, it should be machine project that it should be taken. So this is confusing. Why is why they are not giving consistent result? It is so because this 7% is lower than the crossover rate. So what is a crossover rate? Crossover rate is basically the IRR of the difference in the cash flows of the two projects. So you just find the difference in the cash flows of labor and machine. It doesn't matter whether you do machine minus labor cash flows or labor cash flows minus machine cash flows, okay? You just find the difference and then you compute IRR, and you will see this will give you closer to 9%. And now you see that this number here, crossover rate, is higher than this discount factor rate. Hence the reason why the IRR and NPV are giving conflicting results. As soon as you make this bigger than this rate, then there will be no longer such problems, such as 10% and 10% again. You will see now that both methods, IRR and NPV, are telling you to take the machine one, because you see 26%, and the other one is also higher compared to this NPV 3,700. How are you sure that there can be issues with IRR, isn't it, when they do not match? The other that I would like to, but that's crossover rate, which is shown in the diagram here. 8.763 is considered as 9 here, okay? Now, as another pitfall of IRR, I would like to give you another example wherein you see here there is this project which has this 2 years lifespan, and in this 2 year, let's say for example the cash flows were as follows: minus 800, and then 5,000, and then minus 5,000. Okay. For example, so sometimes IRR cannot be computed. For example, if you change, let's say here, okay, this cash flow, I'll put it here, and let me change this to some number like 50 and try to compute IRR. Then it's difficult to compute, so you don't get it, okay? Whereas some other times you will see that you can compute IRR, but there can be more than one IRR. So here it is saying 25% is the IRR. What does that mean? That basically means if you put this 25% here and then compute the NPV, which is 1 plus this rate and this time period, which is again divided by 1 plus this rate, the year here, the last item, plus this rate and the time period here, okay, add them all together, you get 0. So 25% is IRR because it has forced NPV to become 0. But if you do the same using another number, that's another number I know is 400%, you will still get a 0. Okay, so if you have 28, it is not a 0. But if you have 25, it is a 0, which we found before. But if you change this to 400, it also gives you a 0. So which one is correct, 25 or 400? This is the problem of IRR. When you have more than one negative cash outflows appearing in your cash flows, then you can get multiple IRRs. In order to resolve the problem of multiple IRRs, you can make use of a method called modified internal rate of return. Now, in terms of formula, what you need for modified internal rate of return is future value of all cash inflows and present value of all cash outflows. This is what you need first. Okay, future value of all cash inflows is also known as terminal values or TV. Okay, anyway, what is the future value of all cash inflows? Now this is something we can compute. I am going to make use of the same example, so here, and I will now find out the future values of these. There's only one inflows, which is 5,000, and if you see, future value means this 5,000 invested at 10%, and there is only one more year remaining, which means it can only be invested for one more year. So what will it be after 1 year, at the end of year 2? It will be equal, so you can say here, future value of 5,000 in a year time will therefore be equal 5,000 times 1 plus this rate 10%. Of course, this is just 1 year, so that's what you got. You will get 5,500. Okay. Now you also need to find out what is the present value of in outflows, 800 and 5,000. So that's something you can find out here. This divided by 1 plus the same rate, and then this 0, which is going to give you the same answer. And now this time 5,000 after 2 years will at 10% will be worth less than that 5,000. In fact, will be worth just this amount, 4,132. Now you will add this 4,132 and this, which is the present value of cash outflows. And there can be more than one inflows in, depends on the cash flows. So you can call it future value of cash inflows. Okay, future value of cash inflows. Now just one last step, which is you simply divide the future value of cash inflows by the present. Of course, you need to avoid the minus sign. So you say ABS, which avoids the minus sign. And then what you do is 1 over n. Okay, so that basically means 1 over n is 2 years in total, take away 1. And that's what you get, and that is your modified internal rate of return, 5.60%. And this basically solves the problem of multiple IRRs, because you have applied modified internal rate of return. You may want to see the formula of modified internal rate of return formula, and you will be able to see that it basically can be computed similar to what we've done. Future value of cash flows, present value of cash flows. Here it means negative and positive, or here maybe it is a good one. Future value positive cash flows, reinvestment rate, present value cash outlay, financing cost. Okay, so that's basically the formula which we applied and we're able to find out modified internal rate. This is a simple one. Future value of cash flows, present value of cash flows minus 1. Okay, the one on the top is future value of cash inflows. The one on the bottom is present value of cash outflows. Of course, that 1 over n is also here. That n applies 1 over n. So that's all that I wanted to discuss in terms of the IRR, the pitfalls of IRR. But overall, you saw that such limitations of IRR is not there in case of NPV. The only limitation of NPV is the discount rate, which is required. And the second thing, which is common to all methods, is you need the estimates of your cash inflows and outflows. Of course, that's a big limitation, but to mitigate the risk, you can apply sensitivity scenario type of analysis and see how strong NPV remains even after imposing those sensitivity or scenario analysis. But for your time and listening this video, thank you very much, and keep watching the videos. Cheers. Bye.